so I skipped over some of the initial slides just because it's just a repeat of the stuff you've already done several times now. So I'm starting with, I think, the 5th slide, if anyone's following along with the full PowerPoint. So just like all the others, you're going to do this initial host name, configuration, enable secret, and the lines, both the console and the VTYs. Now, the only thing that's really different here is on the switches, you did line VTY 0 space 15. That's because on switches, there's 16 VTYs, virtual terminals, and on routers, there's only 5. A little secret, you can still put line VTY 015 and it won't yell at you. It just won't, it won't create more virtual terminals, but it'll still work, at least from what I've seen. Now, I've seen that on Packet Tracer. I can't swear that, doing line VTY 015 on a router, a physical device, I can't swear that that won't give you an error. But in any case, just remember, if it's a router, 5 virtual terminals, 0 through 4, switches 16, 0 through 15. And same everything else. I don't know if you did the transport input command yet. It really is, this version of the command actually is unnecessary. The default behavior of the line of the VTYs is to allow both SSH and Telnet, SSH being secure shell. So it's kind of redundant to put it in there. But later on, you will be configuring SSH only on the routers and maybe the switches. In which case, in other words, you don't want Telnet to be an option. And so you'll just say transport input SSH in that case. Another option on most switches and routers that I've seen is transport input all. All just says all applicable protocols, which really is just SSH and Telnet. So transport input all should work as well and mean the same thing as this. But like I said, I don't even know if the lab has you do that or not. But you will need to know the transport input command when you're making sure it's only for SSH. Then you just do that, and it'll won't do. Let me change. It won't do the. It won't allow Telnet if you omit that from the transport input command. And you've done password encryption, you've done banner message of the day. So all of this is the same, except for the VTY command. Copy, running, config, start, config. So that should all be, aside from the slight difference in the line VTY command and the new transport input, everything else is the same of what you've done. What is different is configuring interfaces. So on the switches, you were configuring not a physical interface, right? They called it an SVI, switch virtual interface. And what you did it by saying interface VLAN 1, which is, again, a virtual interface. Its only purpose is for remote management so that you can, Telnet or SSH into it, ping it to make sure it's alive and stuff like that. On routers, you're configuring the physical interfaces because since it's a layer 3 device, you've got to give it a layer 3 address, right? You've got to give every interface that you want to be enabled and active a layer 3 address. So interface, and then you got to give it the type and the number. And the next slide gives you an example of each of these commands as opposed to just showing you the syntax. The description is optional. I think some of the labs you'll do, the Packet Tracer labs and probably the physical lab, tells you to put a description in, but it has no function. It's just kind of like it's like a comment. in the file to give you a little bit of a, like if you're reading this config file later on or somebody else's, you might say under description, like connection to room 215 or something like that. Or, whatever it is, a connection to switch such and such, building 19, blah, blah, blah. So you give it some sort of descriptive text as to what that interface is connecting to. And then the IP address command is the same. You just give it the dotted decimal address, space, and the subnet mask. And the IPv6 address. Now, we don't, I don't even know, I don't think this lab has you configure IPv6 addresses because we do that after we talk about IPv6 in chapter 11, I think. So, but it's showing you here that this is how you would do an IPv6 address. The biggest difference is, of course, the way that IPv6 addresses are expressed using colon, 16, what do they call them? Hextet 16-bit values, four hexadecimal values, or 4 hexadecimal digits separated by colons. And there's a total of 16, 8 of those, 8 sets of 16 bits to give you 128 bits. And so there's no subnet mask associated with IPv6. It's a prefix length using basically CIDR notation. So you would typically, that prefix length is, I don't know of a situation where it won't be. Technically, it could be something other than 64, but it's going to be 64 for our purposes always, which is nice. It makes it easy. You don't have to think about subnet, masks and different values. It's always going to be /64. Because basically what you're saying here is that the network ID is the first 64 bits of the address, and the rest, the other 64 bits, is the host identifier. And that's the way it should be on all IPv6 addresses. So it makes it easier than IPv4, which the host or the network ID could be anywhere from 8 to 30 bits. And the host could be anywhere from 24 bits to 2 bits. And then finally, no shutdown. So you had to do that on the VLAN, the switch virtual interface as well. On routers, every interface, when it's first powered up and has no config file, every interface is disabled, shut down. So if you were to do a show interfaces on a router before you configured its interfaces, the interface would say administratively down. And so if it's administratively down, that's your clue that somebody didn't put in the no shutdown command. Now, there's other ways that an interface can be down. If you configure it like this, do no shutdown, it will be up, but line protocol down, unless you've got something plugged into it going to an active device like a switch. So, there's a few different statuses that you might see an interface. Up means it's up. Administratively down means that it's shut down. And then up, interface up, line protocol down means that there's nothing physically plugged into it, at least not that it's, detecting. Okay, so that is a router interface. Not much to it, but just slightly different than configuring VLANs. And so there's an example. So, these long names for the interfaces, you'll find you can abbreviate like G0/0/0 instead of spelling out gigabit Ethernet. You might want to use the tab completion just so that and again, you also depends on the model of router, or depends on the model of router as to what the interface name is. So one of the things that you might do if if the instructions in the lab don't jibe with the model of router that we're actually using, I think they probably will. But in the event that they don't, which might be the case first, because we don't have all the same routers here. There's a couple, like 3 different models at least. If you do a show interfaces, it'll list all the interfaces and you'll see their names. So that's one way to, find out, how are they named. So you specify the interface that you want to configure. Again, just optional description. If a packet tracer lab tells you to do a description, then it's not optional if you want to get the points. I don't think in any of my skills quizzes, I worry about you typing a description in. So, but in some of the packet tracers, you may have to. Some of the Cisco pre-made packet tracers. IP address, IPv6 if you're doing that. Like I said, I don't think you are for this chapter. And then no shutdown, and that's it. And yeah, so typically what you want to do, and I think the instructions, I think this lab has detailed step-by-step instructions, tells you exactly what to type at each step for most of the things. Of course, the first thing that you should do when you fire up the router and get your terminal connected is what? What's the first thing you should do? Before that, you should erase, start, and reload. Unless, okay, so the one way that you'll know if the startup is already erased, so the someone before you did it right, is it'll give you that initial configuration dialog, which I always want you to say no. Or if you accidentally press enter and the default is yes, just Control-C out of it. I don't want you to do the little prompted configuration of the device. That's not the point. You need to learn the commands. So if that comes up and says, do you want to enter the initial configuration dialog, then you know that there's no startup config, okay? Or it's an empty startup config. So in that case, you don't need to do erase, start, reload. But if it comes up with anything else, if it asks you for a password, obviously, try Cisco and then enable class. Hopefully, if they didn't erase it, that they use the right password for both the console and the enable secret. And if that doesn't work, then we have to do a password recovery. So hopefully we don't have to do that. Okay, so that's the interfaces. So most of the, like I said, there's almost nothing new except the description command. You might even done that for the VLAN and the line VTY04 instead of 15. But the show commands, I don't think you've done these, or at least certainly not all of them. So one of the things to do after you've gone in and configured the router, before you start testing and pinging and stuff, it's always, especially when you're just starting to learn this, is verify your work. And one of the easiest ways, instead of doing a show run and seeing everything scroll by, is do a show IP interface brief. And of course, you can abbreviate that to SH space IP space INT space BR, or however you want, as long as it doesn't say ambiguous command. And that gives you right there a nice summary of the interfaces and the IP address that's been set. It does not show you the subnet mask. So if you mess that up for IPv4, actually V6 as well, doesn't give you the prefix. Then you may have to look at the running config to verify it. But that's a quick, easy way to look at the status of your interfaces in terms of their IP configuration. And the status, up and up is what you want. If it says administratively down for one of your physical interfaces that you're supposed to configure, that means you didn't do no shutdown. And if it says up, and link link protocol down or just down, I think it'll say, then that means that you don't have something plugged into it that it recognizes. So that means you need to connect it to the switch. And then IPv6, same idea with the show IPv6 interface brief. So there's a bunch of the show commands. The other one, show IP route, is an important one. So we've seen, looks like a repeat. So show IP route is probably the next thing you want to do after you've configured the device. Is do show IP route. Now, show IP route will show you the subnet mask in CIDR form. So what you should see if you've configured two interfaces and they're up, in order for them to show up in the routing table, they have to be up and up, both, no shutdown and connected to something. So if you only see one of your interfaces, then that means, the other one's not connected to something live. So you should see two sets of CL. C is the network ID of the interface, of your physical interface, and L is the IP address of your physical interface. And the /32 here, that is not telling you that the subnet mask you assigned is 255.255.255.255. /32 in the L entry simply means it's what's called a host route. Host route is just what it sounds like. It's a route that goes to a single device, a single host. And it's, you ask me, they didn't need to put it in the routing table display. They didn't used to. When I first learned Cisco stuff, we had the C's, but not the L's, but they added those somewhere after version 12 dot something of iOS. So that's okay. That's all it means. The subnet of the interface and the actual interface IP address. Now, once you start doing static routes and routing protocols, then you'll see more routes, that are not C's and L's. But that's not until a little bit later. But we do static routes in here. Don't know if we do dynamic yet until 150. All right, so show interfaces. That kind of gives you the hardware information. It will show the IP address of the interface as well, but it mostly gives you hardware information and status. It tells you errors, any errors that have been seen. So if this was a production device and you didn't have like some sort of fancy management software to collect, statistics, you would go into your interfaces periodically and check to see if there's errors. And if there are, like, let's say the router's been running for 2 weeks and there's a dozen errors, like, let's see what they got. So what kind of errors do they show here? They may not show errors unless there's more than one. Output emitted. I think the error display is after this. So there will be, a list of different types of errors. Well, here they've got runts and giants. But if you see a couple errors, that doesn't necessarily mean there's a big problem. It's if you see some errors and then you come back the next day and that's growing and continuing to grow. That means that there's something that's causing packet errors, and packet errors in today's networks usually mean there's some hardware or some weird misconfiguration. They're pretty uncommon. If you see like CRC errors a lot, which I think is displayed later in the output that's omitted, then that means that you've got something that's causing electromagnetic interference, maybe some bad terminations, where somebody has 2 inches of wire that's untwisted outside the jacket. That'll cause electromagnetic interference or crosstalk or both. So, you look for that kind of thing in the show interfaces if, unless you've got a management station that collects the statistics for you. And then the show IP interfaces command gives you some of the same information like the status and the IP address, but it gives you a lot more IP related stuff. Helper address, which is for when you've got DHCP required on multiple subnets. Most of this are access list information. So if there was access lists applied to the interface, it would be shown here which access list was applied. So all this ICMP related stuff relates to the IP protocol. So if you're not interested in hardware, or let's say layer 1 and 2 stuff, and you're more interested in layer 3 stuff, then you show IP interface. And I think same thing, IPv6 and the default gateway. On the host, how to do that. You just type in the IP address of, the router interface that the host is closest to. And so on a switch to configure the default gateway. So why do you need a default gateway on a switch? Well, the reason would be if this lady here wants to manage this switch, she wants to SSH into it or telnet into it, then the data that she's sending, the telnet or SSH data, has got to go through that router. And switch 1 has to know how to get back to 192.168.11, her network. So if there's no default gateway configured on switch 1 won't be able to respond to her request. So in order to create a default gateway on a switch, you do IP default gateway and then the IP address of the router. That's in global mode, right? You don't configure IP default gateway in interface mode. So you configure the IP address, no shutdown, and then in global config mode is where you do the IP default gateway. On a router, you create a static route. If you want, you create a default route instead of configuring default gateway. So in this lab, you're just going to do a default gateway on the switches. You're not going to configure a route on the router because there's no reason for him to have a default route because there's nowhere to go except the 2 places that he has directly connected interfaces for. Okay, so that is the other additional command. I don't think you've done a default gateway on a switch yet. So that's the additional command you'll be doing. And that was it.